This is experiment 6, calorimetry, and this is the procedure for part B, determining the heat of fusion of water. Now, at this point, I've gotten my ice ready. I have this insulated cup just for this video. When you do this at home, you can go take it directly from your freezer and place it in the water. But for this video, I just wanted to have it stay cool. And here I have my beaker that I've already gotten the mass of. And then I have the mass already with the water placed in there. I have about 100 grams of water, and the water has already equilibrated to room temperature, and you guys can see the temperature here. It is 21.3, so I'm going to write down 21.3 in the data table. Now also with the time, I have already put how we want to take 30-second intervals, just like in part A. So I am now going to go ahead and place my ice here and start taking temperatures every 30 seconds. Okay, so I'm going to stir this. Now, you guys already know that this temperature probe tends to turn off, so I'm just turning it back on now. Okay, so, and I have my phone here with my stopwatch already recording every 30 seconds. Okay, I'll fill in this first data point. Okay, it's already down to 19.6, 19.1. Okay, so now I'm going to go ahead and take this next reading. So it is 17.5. Okay, so now as long as you get close to 30 seconds each time, that's fine. It works. And then what we're looking for here is we are looking for a temperature minimum. Okay, in the last part A, was a maximum. Here we're looking for a minimum. And we want this to, get really good data points for the first 3 minutes, but this may take even longer. Okay, so I'm going to go ahead and take the next data point, which is 13.9. Okay. So while we're doing this, what can we expect from this experiment? Well, we know that to measure the heat of fusion, we're really looking for how much energy does it take for this ice cube to completely melt. Okay, and that's what we're going to try to find. We're going to try to find our delta H. Okay, I'm taking another data point. It's down to 11.8. Okay, and here we know that we're going from a solid to a liquid. So we know that this is going to be an endothermic process. The ice needs energy to melt. That's why it makes our drinks colder. So if I want iced tea, it takes energy from my tea, and energy is going to flow into the ice cube. So that ice cube is consuming all of the energy in its environment. Wow, I'm down to 10.6 right now. And don't worry about the mass of your ice cube, because we're going to get the mass of everything again after we've reached our minimum. Okay, it's turned off, so I'm going to turn it back on. Okay. So here we go. So we're just going to keep stirring. And make sure so notice when I'm doing this, I am not touching, or I'm trying not to touch. No, this is not working. Here we go. Now we're down to 9.7. So I'm a little long on that time, but that's okay. And again, you can get spikes here, right? So if your temperatures get really low, don't be concerned. It just means that your probe is touching the ice, and just continue to get your data. And here I'm down to 9.7 still. So now it's consistently staying at 9.7. And again, I wanted to point out that I'm not touching the bottom of this. I don't want to transfer heat from my hand into the beaker. Okay, it's still about 9.7. And again, we want to do this at least for 3 minutes, but the ice is going to take a bit longer than the last experiment. Or it may take you longer. It's taking me longer. I've done this already, so it did take me longer than part A. Okay, I'm going to take another data point, 9.4. Went down to 9 point. That's 9.6, sorry, degrees C. Okay. So as Dr. Miller said in the video for the enthalpy of the solution, or the salt, excuse me, here's 9 degrees C. Okay, so it's kind of toggling around 9.5, 9.6 now. We want to make sure we go longer. You don't want to have to repeat the experiment, so it's worth just to take the extra time to get all of your data points. Okay, so I'm at about 5 minutes now, 7 degrees C. Oh, my temperature probe turned off. Okay. So we're at about 5.5 minutes now. Let's go the other direction. And now the temperature is staying pretty constant at 9.7 degrees Celsius. So again, we're trying to find our minimum. But this experiment should not take longer than 20 minutes. Okay, so I'm going to take another data point. Okay, now still 9.7 degrees C. Okay, take another data point. Okay, it's actually going up a little bit, 9.9 degrees C. But I'm going to take several points just to make sure that that is my minimum. Okay, so the water will go back to room temperature. So we are looking for the lowest point. Okay, so every 30 seconds, I'm just using my phone. My phone's right here, and I have my stopwatch on, and I am just recording the data points every 30 seconds. Now the temperature is back, it's increasing, 10.2 degrees Celsius. And again, this is going to turn off. It's not a big deal. Just go ahead and turn it back on. And I just, again, make sure that I don't touch the bottom of the beaker. And it's nice with the stopwatch, it keeps track of my total time as well, even though I have all of my data points here. It's been now about 8 minutes. So again, with this, might take around at least 10, but it shouldn't take us longer than 20 minutes. And get as close to the 30 seconds as possible. If you're a little short or a little bit longer, that's fine. Okay, it's up to 10.6 now. And again, I'm just going to be on the safe side. I don't want to repeat this, so I'm going to continue to go. And because I've already seen now that I started at 21.3 degrees Celsius, went all the way down to 9.5 degrees Celsius, and now it's back up to 10.6. So my minimum is the 9.5 degrees Celsius. But here, I'm just getting these extra data points just to be careful. So it's 10.6. I'm gonna at least go to 10 minutes here. I already think I already know I found my minimum, but I'm gonna go ahead and just go do a few extra. Okay, it's getting even warmer, good. So it's 10.7 now, degrees Celsius. Okay, now we're at our 10-minute mark here, and it's about 10.8 degrees Celsius now. Okay, so I can definitely see the trend here. So that's how you'll perform the heat of fusion portion. And if you have any questions, please ask your professor.